Good morning. I'm Lars Svensson. I'm with the German National Library. Alenka asked me to explain what I actually do at the National Library, because this title, Advisor for Knowledge Networking, is something you usually don't find in libraries. So my job essentially is to figure out how we can connect different pieces of data or information out there to build a coherent knowledge network. So that if you have one piece of information, what can I do with it? With what is it connected? How can I get from one piece to the other? And what does those connections tell me when I traverse this network and figure things out? So some people say, well, you're just a linked data strategist, aren't you? And that's roughly right. I'm out in the world looking for interesting facts and technologies, think a bit about it, and say, then I go to different people in the library and say, I think we should do like this. This will be very important for us as a library and makes it easier for other people out there, be they libraries or non-libraries, particularly non-libraries, to reuse our data or information that we have in the library. Because it's been a thing that's been vexing me for more than 15 years, is that library data is very well connected, it's highly structured, and it's hardly known outside of libraries what is actually in there. So 10 years ago, I started on a journey where we said, we in the library started on a longer journey where we said, we want to make this data that we have in the German National Library easier to reuse for people who are not librarians. And it all started off in a way outside of Germany. It started in Sweden, which by coincidence is my native country, but that's another short story. Because in the Swedish National Library, about 2006 or 2007, a brand new developer, straight from the university, got a phone call from a student at the Technical University in Stockholm, asking, you have this large database with all those books and people and so on, don't you? Yes, we do. That's great. Is there a way we can access that data? Asked the student. Because we want to do a project about books. Oh, sure, said Martin. Great, someone is interested. That's good. And said, all right, here's some I'll send you some documentation. This is Mark 21, and here's set 3950. So off you go. It's dead easy. And then the student didn't call back. And about 6 months later, Martin called him instead and asked, so what happened to your project? We're eager to know what people do with our data. And the student said, I looked at that documentation, this Mark 21, it's the ISO 2709, but the semantics weren't quite clear. And this ASN.1 thing said 3950 you got there. There are no Java libraries to do that kind of thing, so we did something else instead. Oh, that's a shame. So what do you need in order to use our data? What formats, what protocols? Well, we learn quite a lot about HTTP and XML. That is what we learn at university nowadays. All right. So, Martin said, in order for people to reuse our data, we need to provide it over HTTP and XML. And that's the start of the first linked data service in libraries, which was productive in 2008, I think. They just published the whole Swedish Union database of bibliographic information over HTTP and XML. And that was the beginning of the story. And since then, libraries all over the world have been very eager to connect those dots within the library sphere and also bringing in the larger knowledge networks out there. And that is what we're going to talk about today. how to build those networks, and also to see what can you do with it. And in the afternoon, we'll also look a bit into the thing, how can you do it yourself with your data? And I can tell you, it's not really that hard. It looks daunting and intimidating at first thing, but the concepts are fairly easy. So we'll start with some 20,000 foot overview, and at a few places we'll go further into the details. So this morning we have a crash course in linked data, particularly in libraries, and in the afternoon we'll go into some more deeper details. Don't hesitate to interrupt if something is unclear, if you have questions, or just want to make a remark, this is how things would work at our place. The point where it all comes together now is that if people want information, or rather 20 years ago, libraries had a monopoly almost on information dissemination. If people wanted something, they wanted to read newspapers they didn't have at home, they went to the library. If they needed reference work you don't have in your living room, they went to the library. Then up came the web, search engines like Google is still around, Yahoo is still around. Who remembers all the web? Who remembers Alta Vista? Used to be the best search engine before Google came. So that is what people use today. They don't go directly to the library. And that means that libraries have to adapt. And the thing we can do is to say, all right, everything that is out there is simply rubbish, come to us instead. I don't think that will happen. So what we can do instead is to provide information to make this search more efficient. Because in my, technically I'm a librarian, although I don't really deal very much with books, and at the heart of my librarianship is that we are supposed to give people access to information that they need, when they need it. If that means that they have to come to the library to consult a reference book, or we can say, well, there's a digital library over there that you can access from home, most information will be there too. Or if there is an undergraduate student, or even school students, we can say, right, read those 4 Wikipedia articles and you'll be fine. Or even when it comes to emergent topics, say, just consult the internet search engine that you trust. This topic is so new, we don't have any information on it yet. And as long as they get their information, then we have served our task as librarians. That means that we have to help to organize things that aren't really ours. So in a way, we're cataloging things that we don't have, or provide information access points to things that we don't have, pointing people to different sorts of resources. And it also means that we invite people to make pointers to our resources, particularly search engine providers. So that is what we do. What we can do immediately is to make sure that our data is out there for others to reuse, because that will make a gateway into our resources as well. Now the point is, as the story with Martin told you, that if we just pushed our data out there, no one will understand it. They won't use it. Or at least the threshold is fairly high. But since the information should be easy to reuse, we need to do something about it. Sort of plug and play for information. You just put it out there, you do it the right way, and things will just work. I mean, a plug and play usually works, not always. As everyone who just plug in a new gadget into with a USB connector into a computer, it generally works, but not always. But that is the vision we have for information too. And by doing linked library data, we can do, not solve all problems, but I think it's a fairly good start. So, going back to the basics, we have something called the semantic web. It's a stack of technologies. It's not quite the same thing as linked data, but almost. You can use them as sort of synonyms. We can go back into the details what's different at a later stage. So the semantic web is built on something called Rdf, that is the Resource Description Framework. And that is divided into things called triples. That is, you've got 3 of everything, and you're fine. So this is what we have here. We have a triple. Well, yes, we have one triple. That has that one, right? You've got something up here. You've got something down there, and you have a connection between it. That's the basic data model. You have 2 things, and you have a connection between them. That's relate. That's RDF in its easiest and most undaunting form. Now, those are the reused terminology from ordinary grammar to actually speak about subjects, predicates, and objects. So you can try to build a sentence of this saying that this thing up here, whatever that might be, has the title poetry. I won't try to pronounce it, you just laugh at me. But this is Slovenian poetry in German translation. Now, one triple alone doesn't make you very happy. I mean, it is a piece of information, a so-called statement. But, and you can do something with it. You know that this thing up there has the title poetry. Interesting, it gets when you start adding new statements to this one. And here are the interesting part, that I reuse something I had referred to already as a subject of a new triple. Saying that this thing has the author, that thing. And just a brief notion on terminology or visuals here. Things in ellipses are things. They are entities. Things in squares are text. So that's the main difference that we talk about. We talk about things and we talk about text. And then we talk about the connections between things and things or between things and text. Right, but what we do here is we start to build a small knowledge graph. So now I know 2 things about this one here. The one is, I know that it's got an author. I don't know much about the author, but at least I can identify it. And I know that it's got this title. So I got 2 triples, subject, object, predicates, or 2 statements, if you want to prefer it that way. And then we can start with more information. Now I know about this thing up here, that it's got a name. It's called Prescheren. Is that the correct pronunciation? Prescheren. Alright, sorry. Prescheren. So now we have a knowledge graph about things. And we can start adding to that one, saying make it a bit more formalized. Because this is sort of hand-wavy. I speak of things, they have titles and names and authors, but there is no formal semantics, nothing I can really look up. So it's more for people to read. They can make sense of things like has author, has name, or has title. Machines can't. Machines don't like fuzziness. Humans can cope very well with fuzziness, but at least fairly well. So what we do is that we introduce something called vocabularies. And they help us to formalize types of resources and to formalize connections between resources. So what I, for instance, do is to, sorry, the wrong one, I mean this one, to say that instead of just saying has title, I reuse things from DC. Everyone heard of Dublin Core? Dublin Core is a vocabulary. It makes definitions of things and relations. And that's what vocabulary is about. So instead of saying it has a title, I said, right, I'll use the title from Dublin Core, and the machine will know, all right, it's this relation. It's well defined. And I use the same to say creator, and already use something from friend of a friend, which is another vocabulary, used to describe people and organizations. They say that it's not just any name, it's name as defined in friend of a friend. And the second thing I did, not just here formalizing the connections, is that I introduced something called types. It tells me what kind of a thing is this one. Because this is only just an identifier. I don't know anything about it until I start adding knots or nodes to this graph. So I say this is a person. I say that this one here, it's a book. And now I know quite a lot about this. And we've only got, what is it, 1, 2, 3, 4, 5 triples. And that's really it. 5 triples to describe one publication, including the author. And then we can start adding more triples, more statements about those different resources, and more connections to other resources. For instance, we could add to this one, to Franz Prescheren, where was he born? When was he born? We could add a date, a birth date and a death date. We could add another of those ellipses here, being a place, the place where he was born, the place where he died. And then we can reuse data from other places, from outside of the libraries to do that. Now, so how do we identify those things? And this is a small, short excursion into identifiers. We need to be able to know what we talk about. And when we agree on how to do that, we can always know that we talk about the same thing. And that's a good advantage. Because sometimes it's helpful only to say, I don't know what that is. But if we can agree on an identifier for it, at least when we exchange information, we can know we talk about the same thing. And that's helpful too. We have a very large scope when it comes to identification, because we want to be able to identify everything, or at least everything in our universe of discourse, everything that is of interest to us. They must be globally identifiable and globally unique. That means if two people use the same identifier for one thing, we must be able to ensure that we really talk about the same thing, or the system will get confused. This is also one of the differences between people and computers. It's sometimes easier to confuse a computer than a human, because people sort of think out of the box and no, that doesn't work. The computer can just like, well, you got an inconsistency here, but I can't solve the problem for you. We've got something called the generic URI syntax. Who knows what a URI is? It's a uniform resource identifier, defined as something called RFC 3986. It's essentially a string of characters that adheres to a specific syntax. That's it. And they can register URI schemes and so on, and they mean different things. The important part is that they've got, sorry, wrong button again. They've got something at the beginning here saying what kind of an identifier is this. And then they have a syntax behind, and they can start delegating things, saying that things that start with d-nb.info are handled by that organization, or things that start with NBN are handled by that organization, or things starting with mail to, well, that's a bit hard to know because you never know who handles that kind of thing. But those are different kinds of identifiers. All of them are unique. And if we go back again, when it comes to identifiers, Those are the things standing here in the ellipses. When you are in RDF, all those things here are identified by URIs, Uniform Resource Identifiers. Any kind of them will do. And another thing is, those relations here are also identified by Uniform Resource Identifiers. So this one is also a Uniform Resource Identifier. It's got a tiny bit different syntax, but that is a URI too. We'll look 2 or 3 slides later. We'll look at what does this actually mean to a computer. Now the point is, someone will of course ask, well, why do we need so many different kinds of URIs? Well, sometimes they're tied to a specific protocol, for instance, like SMTP or HTTP or FTP. You can transfer data using it. Sometimes it's also a matter of expectations. Those of you who are into digital long-time archiving will probably have looked at URNs. Do you use URNs, Aleka? Yes. You do, right. Because if we look at one of those HTTP things, this is a question for the audience again. When you surf the web and you click the links, you use HTTP, even if you don't think of it. How many of you have not clicked a link and you land on a page saying 404 not found? Right, everyone did. That is the point. With HTTP, you have no promise of persistence. No one can promise you that that resource you wanted to get isn't gone. There are some organizations that say we have policies in place. The W3C, the World Wide Web Consortium, they do that for parts of their website, saying that everything that is in technical recommendations will be there infinitely, or at least as long as the web works, whatever comes first. URNs are different because there is no protocol behind that. It's just a name for a resource. And then you can delegate the namings of those resources, and thus the persistence, saying that this name is always tied to that resource, to an organization. And that organization can then promise, all right, we say that this will be true until the end of the universe, for as long as there are URNs, whichever comes first. Mail chains are very volatile, of course, because you never know if the person you want to send, or the mailbox you try to send an email message to is still around or not. You might get the message, sorry, there is no recipient. I think that's SMTP 550 or something. There's a status code for that. So, sorry, I don't know this recipient. Try again. With another address, that is. So that is, we got different expectations on resource persistence coming from different URI schemes. And we also got different expectations on the resolvability. Can I get this resource just by invoking a protocol, which you can with HTTP, but which you can't by using URNs, because there is no protocol tied to URL. There are people in IETF who say, well, there are mechanisms around, we could try to use something called triple DI, but it's not implemented yet. So today we can say there is no standard resolving mechanism for URNs, but there is a promise that they will be stable. So you have different expectations for different kinds of resources. So why do we need this global identification? Well, as librarians, we all know about the homonym problem. Things look as if they were the same, but they aren't when it comes to textual space. If, for instance, looks at titles, we've got things like document titles. The question is, what kind of title do we have? Do we have document titles, personal titles, academic titles, course titles? When you go to university, you attend a course, and that course usually has a title or a name. And we need someone to say, well, that is this kind of title, and that is that kind of title. Sometimes it doesn't matter. Sometimes it does very much, because you don't want to confuse them. So that's why we introduce something called namespaces or prefixes. So we've got the Dublin core title for document titles, and the FOV titles for persons. We've got something called the ontology for the integrated authority file, the D Ontology. It's got something called academic degree, which is academic titles, professors, doctors, and what you all have. And they have course titles. There's a namespace or vocabulary for describing courses too. And we can use those to differentiate between them, saying, this is this one, and that is that one. Humans might not even notice, and they might not even care, but it makes it easier for the machines to figure out what do I try to describe here. Here's the promise I had before. Yes, so what about those URIs? I mean, we had those looking like this, all written out, starting with the protocol and then going to the end of the string. Something that looks similar, those, where you just have a something, a colon, and a something else, a short name, so to say. And what do those mean? Well, it's simply two ways of writing the same thing. This few letters you got in front of the colon is something that Rdf took up from XML namespaces. It's essentially the same syntax. Doesn't mean quite the same, but they're very, very similar. So it's called a prefix in Rdf, and it's something you can expand. So instead of having to write all of this, we can write this instead. And then we have to tell the computer, the system, whoever, that when I just write DC colon, I actually mean all of this. So DC colon is http://perl.org/dc/elements/1.1/. And then you can just glue the pieces together for yourself. And the same works with the G and D ontology, where you've got G and DO being a fairly long prefix string. It's this one. I learned that one by heart now because I use it quite often. And the courseware ontology vocabulary, and so on. And so just take the first part, you expand it, you take the local part, and you glue them together. And for those of you who can't remember what all those are, I'm being one of them, I want to point you to a nice little application called prefix.cc, where people register their vocabulary namespaces and the preferred short versions of the preferred prefixes. And there's even a voting mechanism in there, because when people start to use the same prefix for two different namespaces, that will confuse. So again, the community can then vote and say, I think that this is the right one and that is the wrong one, because that is the one we use the most. So if you haven't been there yet, served by at prefix.cc. It's a very neat little application, very easy to use. And it's also quite often used by other applications to do reverse lookup. That means if someone supplies this, they will go to prefix.cc and figure out, all right, that is DC. They actually mean that one. And important terminology. Technically, they are called prefixes, but if you call them prefer to call them namespaces, that's fine too. People will know what you mean. So, we have talked about triples, we have talked about vocabularies, we've talked about URIs. So, what do those vocabularies actually do? where they allow us to specify kinds of things and allow us to define or talk about relations between things. So that is what vocabularies are about. Then we've got the actual data that they describe. So we've got those two different kind of things. The one being the data that we have, that we want to describe, and the things we can use to describe that data. And on top of that, we've got the syntax, RDF, Resource Description Framework. So what do we want to describe in libraries? Well, we've got all kinds of things. The first thing people usually think about when they go to a library are books. Some people think of newspapers or magazines, but most people think about books. So let's start with that one. We've got books. We've got persons. I call them authors here, but really we would call them persons too. We've got places. Where do we publish books? Where are people born? Where do things happen? They happen in time and space. We've got the people who bring us the books. We've got the booksellers. We've got the publishers. We've got more people called editors. We've got topics to describe the books or the publications we have, and so on and so forth. So we've got quite a lot of different things of interest we want to talk about. And that makes it slightly more complicated than it is for people who have a very, very narrow scope of focus, what they want to describe. On the other hand, there are people who try to develop vocabularies for the automobile industry, and they go into details. I can tell you, all the bearings, all the motors, all the different parts of cars, that is quite a lot of information they need. And they describe that very, very, very narrowly, because they build processes, manufacturing processes, on top of that. So it's not easier anywhere else. So how do we do when we create such a vocabulary? When we try to figure out how can we describe our things? But it's a bit like forensic or cataloging, if you prefer to look at it that way. That we actually have something and say, I want to solve a problem for this one. So you take a publication, a book, serial, whatever, and you look at it. And those things we look at when we do this are so-called individuals, as opposed to what we call later classes and properties. So we have an individual. Individuals can be people. It can be one single computer. If I want to talk about this computer is an individual. Everyone uses an individual too, by the way. So, and we try to look at this and say, all right, we've got different kinds of things here, and try to figure out what kinds of relations do we have. So we have a German translation of Franz Prescheren, that's right? Right, learned something. Published by something called Trophenic, that is situated in Munich. And we also have something called Das Glasperlenspiel. I don't know what that would be in Slovenian. It's the glass bead game, is in English. But, right, never mind. It's a publication we have in front of us. Written by Hermann Hesse, published in Berlin by something called Surkamp. And then figure out, right, we've got relations. We've got this thing here. Prescheren wrote that. We say that first. Trophenic published. And Trophenic is situated in. So that's kind of relations and things we figure out from this resource, this individual we have in front of us. Then we put those descriptions side by side and start to look for similarities. So we've got something up here that both have the relation that they wrote something. So we don't know exactly what they are, naively spoken. We have an idea, of course. Well, those are people who wrote books. They're easy. Might be, might not. Sometimes it's better to take a naive approach instead of think that you know everything beforehand. All right. Then I have things here that have the relation published. And there are things here that are related to those published things by something called situated in. That's what we know at first. Then from there we go on, and then we can then introduce something called a class. A class is, I don't know the exact mathematical definition, but a class is a group of things that have similarities or commonalities. So you can say that up here, those who have the rote connection to something, we call them perhaps first writers, because they've written something. Here, those have published something, so we can call them publishers. And down here, well, if you situate it somewhere, that is at a place. So we can introduce three different classes here, being writers, publishers, and places. And mind you, we still haven't looked at those things here, because they are a bit harder to grasp. We don't really know much about them, because all the links coming to those things are inbound. They are defined by the relations that others have to them. They don't have relations themselves yet, and that makes them a bit harder to grasp. I define myself by the relations I have. Others define me by the relations they have to me. And those are two completely different things. Ask your local psychologists, they will tell you all about it. So, what we could do, finally, of course, was to say, all right, we got here the published relations going into the notes of poetry and board game. So if someone has published something, we can call it a publication. Eventually we'll come down to that one. Now the point is, all publications aren't equal. We've got different kinds. And that can be very important if you want to find the right publication. Because sometimes you're not interested, you don't know much about it. Or you're not really interested in one specific publication, but you're usually interested in perhaps a group of publications, because you want to explore them as a group. So you're searching for publications that have similarities, or that can in some way be bound together to a set or a group. And that is why we perhaps need to look a bit more closely at what kind of publications do we have. And by the way, the same is with people or places. You can bound places geographically, places that are nearby one another. You can bound places by, are they cities or are they villages? You can bound places by, are they capitals or are they just regional capitals? And so on and so forth. So you can build your sets of things in very, very different ways. And this is also where Rdf can help you, depending on how you define your vocabularies. And this is a very important concept too. You must remember all those vocabularies that are out there, all those ways of partitioning the world into different sorts of things are man-made. No one can say this is right and that is wrong. You're all allowed to build your own view of the world when it comes to your bibliographic data, or anything you think is important to you. That might or might not overlap with what others think the world looks like. But that's a different concept. We'll touch on that again, I think, a bit later when we talk about interoperability. Because interoperability is always easier when you have the same worldview, when you sort of agree on, right, let's call those kind of things, having those criteria, we call them an X. And those kinds of things that have different criteria are totally different from the X's, and we call them Y's instead. But that's up to you. All things don't have to be equal, and I think that's a very good thing. Although it makes interoperability a lot harder when things aren't equal. All right, so what do we have here? Down at the bottom, I have 3 publications. I can say that those 2 have the type lyric poetry. And this one, Die Stadt by Hermann Hesse, is a short story. Those things have commonalities too, by the way, because they're both written by Hesse. This one is Breschel. I like it. Now, the point is, if I want to search for all lyric poetry in this database, I would say, all right, I can go to a reasoner or some kind of search interface and say, give me everything you have that is of the type lyric poetry. And I will get those to you. Then I can say, all right, I want all short stories. Now we'll get this one. And possibly other ones too. I mean, this is a very, very small database with only 3 items in it. But I think it proves the point anyway. Now the question is, what do I do if I want to search for everything in the database? Of course I can say, give me everything. All right, it could be easy, depending on how large the database is. If it's 3 items, fair enough. If you've got 3 million items in your database, you will need some time to browse through that result list. So what I can do is that I take my types up here and I introduce a hierarchy, saying that those are types of literary works or types of publications. And I can say, all right, but they've got something in common. They are both literary works. So I can introduce a hierarchy of classes. Lyric poetry and short story are classes. They are things that have, because they join things that have data in common. And introduce a new class called literary work. And then I can say that lyric poetry and short stories are subclasses of that one. And now we come into an important cornerstone of the semantic web, which is it's very much built on logic reasoning. Which means that there are software in place that can help you to take those things apart and pull them together again the way you would want it to be. So, I could say first, all right, give me everything of the class lyric poetry or everything with the class short story. And if I didn't have this one, it would be hard, because I would say, right, I want the union of the query for lyric poetry and short story. But instead I could say, give me everything that is of the type literary work. Now the point is, there are no connections from the actual data in here up to the literary works. See? No arrows pointing to anything. But the Rdf system will know anyway that those are of the type literary work, because we have this subclass relation. Because the subclass tells you if something is of a class, and that class is a subclass of something else, then it's automatically a part of that superclass, or a member of that superclass, not a part of it, a member. And that is something that you in a common library system can't do, because those connections between classes and superclasses simply aren't there. And that's where Rdf, or the semantic web technology stack, can help a bit to figure that out. So far clear? If it's unclear, just stop me and say, sorry, I don't get that. Can we reverse 13 slides and start over again? So, yes, what did we have? Yes, different kinds of publications. And as with publications, we also have different kinds of names, the so-called properties. Those arrows are in Rdf speak called properties. Doesn't have the types are called classes. Because the point is, we can define things differently. We've got the ball bead game, Glasperlenspiel, that has a title in Dublin Core that says, well, this book is called the Glasperlenspiel. We also have the short story, Die Stadt, and we know those were written by Hesse, and we have a name for Hermann Hesse, which is a very, very long property. It's the preferred name for the person, which shows you that we are deep into library land here, because we talk of preferred names, we talk of alternate names, pseudonyms, and all those things that librarians like to keep apart. Say, no, those are not the same names. Most people won't care. Librarians do, and I think it's good that someone cares about it, because it does make things easier. And if other people start to care about it too, they can just reuse our data. It's there already. Isn't that great? All right. So what we can do again is that also with the properties, we can introduce hierarchies of properties, saying that a preferred name for the person is just a special kind of name, of the kind we call name in the friend of the friend vocabulary instead. So you can do the same thing. If you don't care what kind of name you get for your person, you can just search, all right, give me the name, the host name, and the so-called reasoner, that is the piece of software that knows everything about those hierarchies, will just go down its property hierarchy and say, all right, the preferred name for the person is just a special kind of a name. So if people ask for names, I can give them the preferred names instead. And that also makes it easier for us that describe the data, because we can go deep into the details of all kinds of names and saying, all right, this is that kind of a name, and this is that kind of a name, but we can all join them together as names. So you can do the general search if you want to, or if you don't know exactly how the names are organized. And if you are explicitly looking for pseudonyms, you can search for them as well, because the data is in there, and you just have to know how to get there. So just as with the here, where you can search for any kind of literary work, if you don't care what it is, you can say, give me all literary works, those up here, written by Hesse, you will get those. If you just say, give me all literary works, you get those. So you can join in or narrow in on your search results in very many different ways. And the software is out there to help you to do that without you having to define different kinds of indexes in your search engine. The system will take care of that. It's got other issues though, so it doesn't solve all your problems, but it's another way to look at them. Let's put it like that. So you've got the same thing here. You search for, just for the name Hermann Hesse, you will find this one. And also we see here that up at the very top we have something called an RDFS label. RDF is the Rdf Schema vocabulary. and it's got something called a label. And that is supposed to be the one thing, if you want to present something to an end user, and you don't really know what it is, and you don't really care, you can sort of just ask down in the database, right, I found you, you are the thing I was looking for, and just give me your label. Whatever that thing means should be the proper thing to show to an end user. That's what we call the label, the RDFS label. And we can put that one into the hierarchy too. So the fourth name is a sub-property of RDFS label. So I found Hesse, I want to present that data to an end user, not in the library, just anywhere, and it says, right, give me the label, and the system will know, all right, the label, if I want the label, I can go to the fourth name, and the fourth name will say, right, I can go to the, those buttons are too small for my hands. I can go to the preferred name for the person, and just deliver that one back up here. So that is the strength of these hierarchies that you can organize. And mind you, those can be multi-hierarchies too. There's not the one right hierarchy, but at least it helps you to organize things. And if it's well documented, you will know what each vocabulary means with an RDFS label. You can do the same things, or what you would wish, of course, is to say, right, I found, it's the right button, I found the book, and I don't know exactly what the book is, so just give me the label so I can show it to my end user. And the bad part is you can't, because this connection between Dublin core title and RDFS label isn't there. I nudged the people from Dublin core a few times to say, wouldn't it make sense to add that one? But I said, no, we don't think it's the right thing to do. And there's only so much you can try to convince people to do what you think is the right thing. If they don't think it's the right thing, they won't do it, no matter how long you ask. So I think that solves it about hierarchies. We've got the class hierarchy, we've got the property hierarchies. They work very much similarly, although they are technically different things. So we've been looking at so far, we have looked at the general data model, triples or statements, subjects, predicates and objects. We've been looking at identifiers, the URIs, the uniform resource identifiers. We've been looking at different ways of writing the uniform resource identifiers. We can write them all the way down, starting with URN colon or HTTP colon or whatever you want it to be. Or we can use the compact form, which is, by the way, called a CURI, a compact URI, this compact syntax, where you just write a short prefix, a colon, and then sort of the local part of it. And then the machine will know how to put them together if you say what the prefix is. We've been looking at how to figure out what you're really talking about, but by looking at individuals, finding commonalities, building classes, introducing class hierarchies to talk about things at different levels, and how you can use that when narrowing in on resources to figure out what you really want to see when you search. Slightly later we'll look at how you can search in RDF data. What else have we done? We looked at hierarchies of properties, saying that there are different kinds of labels, and you can just define that if you have describe something, this is the label you would want a generic system to use. And that things only work as far as someone actually defines those relationships. And you can find anything for yourself. And when it comes to cooperation, when you want to reuse things that someone else defined, you need to figure out, do they describe things the way I think they should be? And if they do, fine, just reuse it, as with Dublin core title or fourth name, for instance. But also that there are some issues that they might look at things slightly differently from the way you do. And then you have to ask yourself, can I live with that? Is that okay for my use case, for my use of this data? If yes, all right, fine. You tweak your own requirements a bit and it works anyway. If not, you have to figure out, all right, so what do I do? Which generally means you have to define something of your own division and try to fold that into the system and build those class and property hierarchies to make sure that it works nicely in a larger context. This makes things easier in one way, because if the model you have in front of you that someone else built doesn't work for you, in Rdf it's very, very easy to, technically spoken, to build your own model and sort of just fit it into the larger system of data. And the machines will know what to do with them. It's harder because A, you really need to know what is my data. And of course it makes interoperability again a bit harder because other systems might or might not exactly know what is meant. So you've got your trade-offs as everywhere. It's like defining your own mark format. ISO 2709 is to ISO 2709. Every system that knows how to deal with ISO 2709 data, that is the ISO data model that Mark is built on, will know how to process it and how to take it apart and say this is the field and that is the subfield and that is the contents. When it comes down to what do those contents mean, you've got another issue. And that is the next topic we're off to now, is to not only talk about the data models, that is the semantic part, what does the data mean, but also talk a bit about the syntaxes. I have put this a bit on top, or reversed the way to look at this, because when you talk about semantic web and linked data, it's quite often important to talk about the semantic part first. So that is the main question we need to look at when we transform our data in order to get it into the larger network, is what does it mean? What does it mean to us? What does it mean to others? And then, once we've got that settled, it's fairly easy to transform the data into a technical format that the others can understand. And when I say understand, it's not only to figure out how do I take this long string of information apart into pieces that I can understand, technically understand, but also to see what can I do with them. Where do I put what piece of information into my search engine, and what do I display to an end user, and so on and so forth. As I said, don't hesitate to interrupt if I get into technical or too philosophical along the way. So far we have only looked at ellipses, rectangles and arrows. It looks nice for people, you can see how the graph or the network is built, but it's not really helpful to machines. Machine needs something more technically precise than just sort of hand-wavy diagrams. And Rdf comes to our help there as well, because what we've been talking about so far in Rdf is a so-called abstract syntax, which essentially says there are things we talk about, entities, we have text, and we have relations that tie those things together. Entities to entities or entities to text. That is what we have. And the question is, how do we make that machine readable? Or even, I mean, such a diagram is of course machine readable in the technical sense, that you can, it is a digital format and you can use it on a computer. That doesn't mean that the computer understands what it is. And of course that is the part of the semantic. The computer is supposed to understand what we are talking about. And let's have to check how we are for time. Yes, this looks quite nice. And in RDF, when it comes down to those exact formats, the syntax, how we can exchange information between machines, those are called serializations. It's a computer science term. When you try to serialize data, it's actually how do you make it into a stream of bits and bytes using a predefined syntax with a predefined semantics. In RDF, there are more of those than you would want it to, but they all have the pros and cons, and they're actually used everywhere. The first one is called Rdf Xml. It was the first one. One of the first applications of XML, by the way, as well. Hard to read, very imprecise. We'll look at a few examples afterwards. Imprecise in the sense that you can write the same thing in very, very many different ways. Which means that you can say that this is a canonical way of doing things, because there are so many ways of expressing the same thing using this XML syntax. So later they introduced something called Turtle, which is terse triple language. It's nothing to do with nice little animals. N triples, which is extremely verbose. That means you've got an awful lot of data to look at. Hard to read for humans, but what is use cases? I like it very much for certain uses. And the new kid on the block being called JSON LD, which has lots of curly brackets in, and which is something that web developers like to use very much, because it's compatible with something called JavaScript object notation. And those of you who are into JavaScript development will know what I mean. I said this is great for that use case. But let's have a look at them one after one. Sorry, wait, what? Yes, this one. So we're back at Prešeren again. This is the graph we had at the beginning with, what was this? So 5 triples, I think, are in there. We've got the one with the title, we've got the one with the creator, the one with the creator's name, and 2 types. So that's max 5. So this is the data that we want to have in sort of the abstract syntax. Talking about entities, texts, and relations. Those classes are, by the way, entities too. There are things we can talk about. You don't talk very much about text in the semantic web. We like to talk more about things. This is what I would look like in Rdf Xml. One way of expressing it in Rdf Xml. If this is hard on your eyes, I don't blame you. It's terrible to read. But it's got all the information in there. So I think we should start here. This is the definition that we have here that introduces this entity, saying that it's of type book. And that we write like this. So we start by stating what kind of beast do we have, and then we say, and by the way, this beast is called like this. This is the name, the identifier we have for it. And up here, in the namespaces section of the XML document, we also define somewhere that the prefix for BIBO, that's a bibliographic ontology, is this one. So that would help the software to build a URI for book. And implicit here is also the type. You see, it never says that this is only the type, so that's sort of implicit in this syntax. And then we have the name. And once we've done that, sort of within those book section here, we say we've got the title and we've got the creator. And if you don't know what the DC or DCT is, you go up in the namespaces section and that is defined there. So that is our book. And then we start with the person instead. So instead of us saying, all right, I'll link those things together, here, these and these are the same identifier. I'll start by saying, all right, now I'm defining a person, and by the way, here's the name. And then I say about this person, that is the identifier of the thing I'm talking about, that is a person. And then I go to say, all right, it's called Franz Prescher, by the way. So that would be my 5 triples. We've got one up here, one down here, doing the type, that makes 2. We've got one with the title, one with a link from the book to the creator, and one with the creator's name. Make a total of 5 triples. And then there are at least 5 different ways of writing this in Rdf Xml. One being harder to read than the other. The reason that this one is still very much in use is that it was, for a very long time, the only one that was standardized, that had stood in specification. This is the standard way of serializing RDF data, is to use Rdf Xml. Then came Turtle and a few others, but those weren't standardized until very much later. So that is the point why this one is still around and still used. Not by people. You don't really write data in RDF like this. You use one of the others instead because they're much easier to read and write. So we've got the same thing in Turtle. First triple language, which was invented because there was a time, like with HTML. How many have you ever written HTML using a text editor? You know what I mean? Yes. So at the beginning of linked data semantic web, people actually wrote RDF using a text editor. And you can imagine writing the XML thing here using a text editor and trying to figure out that all pieces were in place. It's hard. I've done it. So they said, right, we need something that is easier for humans to read and write. So up came Ter's triple language. So here again, we got over 5 triples. They go the other way around, by the way. They start with an identifier for the thing we talk about, being this one. And then it uses the to say this is being the type of the thing. This is a book. And if you don't know what biro is again, you go to the top of the document where all the prefixes are defined. So you've got all the prefixes in one place, neatly one below the other, easy to find. If you want to make it really easy for humans to read, you organize them alphabetically. I haven't done this here because with 5 it doesn't matter really much. We got documents where we got 30, 35 different prefixes to manage. And then it's easier for humans to read if you just organize them alphabetically. You don't have to look around very much to know where to find them. And here's a mistake. Agile fixing of things. Oops. Look. Oh, well, right. At the end of the line, you now see a semicolon. And that tells me, or rather it tells the computer and me, and anyone else who reads this document, that you keep using the same subject. So what comes next reuses this subject and just adds more information to it. So I've got one triple up here, and then I've got the second triple sort of goes here. So I'll still talk about this book, and then I add the information that the title is poetry in German translation, or selected poetry, I think, as well, right. And then comes the semicolon again, and it makes the link to the creator, saying, oh, you got a creator, and this is what it's called. And if you don't know what a DND is, that's the integrated authority file, gemeinsame Normdatei, which is the authority file we use in the German-speaking part of the world. Just look up here in the prefixes again. And then comes a full stop, a period, and that means stop reusing that subject. Now we talk about something completely different. And then we start all over again. Okay, I now talk about this thing here and define that this is of the type, this is Rdf type again, is a person, and that's the name is Franz Krescher. Full stop, period, end of document. So we've got the 5 triples again, neatly lined up, one on each line to make it easier to read. And it also makes it very clear, here I talk about this one until the full stop comes, and then I can start to talk about the next thing. So it's very entity-centric in that case. If you do the if you put things to the right, at the right place, like here, if you indent properly, here, it will make it easy to read and say those things belong together. Indentation. Well, never mind that word. You indent properly and you'll be fine. The machine doesn't care, by the way, but it's good for humans, and this is for humans to read and write. So what do we have then? We've got n triples. Oh yes. Very verbose format. It works like that you always have, no, let's go back. Here, we can use the compact URI syntax, using prefixes, colons, and local names. In n triples, you can't. In n triples, you always write the full URI, from the beginning to the end. And you put it in angle brackets, as you quite often do in technical documentation with URIs, by the way. So you start with the subject, here, in angle brackets, a blank, then you have the type relation. It really looks like this. It's very, very long. A blank again, and then you have the object saying that this thing is of the type book, and then comes a full stop. And if you do it really correct, if I did it really correct, you couldn't read it. It all has to be on one line. And then you end that line with a carriage return. No, you don't. You end it with a new line. 13 in ASCII. And then you start all over again, saying, I talk about this thing, the subject. This time I have a different predicate. I've got the Dublin core title. Again, the full URI in angle brackets. And then, in quotation marks, comes the text. And at the end of the line, a full stop again, and a new line. And it goes on like this for every triple in the document. So it's one line per triple, all URIs written out, and the literals, that is the text, goes in quotation marks, and at the end of the line you have a full stop. All separated by one blank, one piece of white space. Now, it's a lot of text, hard for humans to read, because you really have to parse the URIs and try to figure out what is this one again, what is the prefix and what is the local part I'm looking for. And still, this is something that when I try to define what RDF should look like, I use this every day, several times. Why would someone want to use this kind of syntax? That is hard to read and hard to write. Because it's unique. There's only one way to write a triple or a set of triples using the n-triple syntax. All URIs written out in angle brackets, one statement per line. So that is, if you try to do automated system testing, where you see, I feed this data, a bibliographic record or whatever, into the system, and I want exactly those triples to come out on the other side when you define data conversions. This is superb. Because I tell my automated testing systems, feed in this data and look, downstream string comparison, is this line somewhere in the document that comes out on the other side? So it's superb for testing, but don't use it for anything else, really. Particularly not if you want to read it. It's hard to read, hard to write, but for those things where you really need uniqueness of triples or uniqueness of data that comes out, really great format to use. So what's the last one? Yes, JSON LD. JSON is something called JavaScript object notation. JSON was first, by the way. JSON was before JSON LD. And it was a format that has a lot of impact, a lot of take up in the web developer community, because it fits very, very nicely in with a programming language called JavaScript, or ECMA-262, I think is the proper name. Everyone knows what you mean when you talk about JavaScript. It's the thing that services like Google Mail use to build the user interface. You can manage data on the screen, thus pull it in from outside, and you can make very nice visual interactions with it. I can't do it, by the way. I'm absolutely new when it comes to JavaScript, and it's more or less voodoo to me. But I know that people can do all sorts of nice things defining user interfaces with JavaScript. And this, with all those curly brackets, fits very, very nice into the object model of that programming language. So people started to exchange data using JavaScript object notation, called JSON. And then was the question, right, but we don't have JSON, someone said. We have RDF. So you can't use our data, or you can't use, or we can't use your data, or we can't use, it doesn't work, people figure out. So right, the question was, how can we represent RDF data in JSON? And particularly the question was, if I have data that isn't JavaScript object notation, and I don't really care much about making that into Rdf Xml, or Turtle, or n-triples, or any of those other languages or serializations that RDF use, what do I do? Alright, so people went off, thought a bit, and said, alright, we'll introduce something called a context. So that means that if I'm down here and just talk about 5 persons, or even persons, I could just leave the 5 away, and say that if I speak about 5 or person, I define up here in my context, a bit like in the prefix part of a Turtle document, how people can expand their data to make RGF out of it, or even how you can take a plain JSON document that isn't really very specific about types, you can sort of from above, from this context part, impose a more specific semantic on the data that is in there. Because if I just write here, if I just write name, Hans Pesel, it could be any kind of name. Or here, if I just had written title, I can do that very well in JSON. Just say, well, this is the title. It works perfectly as long as there is an agreement between the sender and the receiver of that document, what exactly we mean by a title. But again, those are conventions, agreements. And if somebody else starts to use that API to pull in data for their application, they either have to read the documentation very carefully, if there is one. Everyone who's developed software knows that APIs are notoriously under-specified, badly documented, and the best way to get information is to try to write an application, it breaks, and then you use the mailing list afterward to figure out what went wrong. That is how very much software is developed. So instead they said, all right, we need to be more specific about the semantics in JSON while still being able to use it as JSON without actually changing anything of the document. So in comes this context where you can define prefixes or even the exact meaning of what the name is, and then you can turn that into RDF. So you win two things. You win the exact specification of what the name is, or a title. You looked at 4 or 5 different kinds of titles a bit earlier. And the second part is, this is RDF. So if you like to work more with RDF than you like to work with JSON, this is fine too. So it really ties those two worlds together. The semantically very specific part of RDF, the semantic web, while also keeping it fairly low key, making it easy to reuse the data in the context of web application development. So this is a very, very popular format to use. We started to push out data in JSON LD fairly lately at our place. I think it was 6 or 8 months ago. And we've seen a very good uptake on the use of that data. So that is serializations. So we had the difference between the abstract syntax, which is entities, text, and the arrows that knot them together. Nice to look at for humans. You really see how the graph is, well, ties the things together, how the network is built. But in order for machines to make it work, you need things like JSON LD. LD is linked data, by the way, so it's JSON as linked data. Or M triples, or Turtle, or Rdf Xml, the so-called serializations, in order to make it work for you, to make it really work for you, for data exchange between machines. Right. So we'll touch very, very briefly on something called Sparkle, which is one of those reverse acronyms that some software people like very much. It's called Sparkle Protocol and Rdf Query Language, if you spell it out. And as you see, in the expansion of that acronym, Sparkle, you have the word Sparkle in there. So no one actually means what Sparkle, nobody actually knows what Sparkle means. It doesn't, it's done that. But it's an Rdf query language invented in order to query those graph networks of information that you get in Rdf. So it's a bit like Turtle. You start up here by defining prefixes. We've seen that before. The difference is that you don't start them with an @ sign, but just write the word prefix. but they are in the course of fixing that, so that you really just be able to transfer data back and forth between Turtle documents and Rdf and Sparkle queries. Then, like in SQL, for those of you who are into SQL, you start with a select clause, for instance. Say, I want the title. And if you make a small question mark in front of it, the system will know this is a variable. This is something it has to figure out what it is. And then the real work is done in the where clause, which again should be familiar to people who do SQL. And then we start building up the graph as it would be in the database. So I say, all right, I know that there are books in there, and then those have titles. And this is the title I'm really looking for. I also know that books, then we have the semicolon, as in Turtle, saying that we still talk about the same book. Those books have creators, and we call this creator here, in this query, we call that one an author. Still doesn't tell me, we still couldn't answer this question, because I don't know yet who the author is. So I have to add another slide query, saying, all right, and this author, which by the way is someone as that author, should have the name Franz Prescher. And if we, have I been, no I haven't, let me go back a bit, like this one. So what I want to have is this. The only thing I know when it comes to text is that. But I also know how those things are connected. So we have books, things that are books, that have titles. I know that the books have authors, and I know that the authors have names. So I can sort of traverse this graph backwards, saying, all right, I start with the name, find the author, find the publication, making sure that it's a book, by the way. And from there on, I go to find the title. And that is what I do here as well. I start off then by saying, all right, get me the author. And I say, and the author should be the creator of a book. And that book should have this title, and that is the one I'm looking for. So you sort of traverse the graph backwards, which means you have to know, of course, beforehand, how the data is organized. What kind of things do we have, and how are those connected? But there are ways of figuring that out too. And this is not something that you would give as a user interface when people put queries into your database. This is something that should go behind the scenes. That is, you don't let people write SQL statements on your system's database if you have an SQL server somewhere at the back end of your technical infrastructure. You hide that between a nice shiny user interface, say, right, you enter this one there and that one there, and then we'll do the hard work for you. It does present nice result lists. But if you have data that is organized as RDF or in RDF, this is one of two ways of searching for it. There is a new one called triple pattern fragments, but we won't go into that one here, because you usually hide triple pattern fragments, or TPF, behind the Sparkle endpoint anyway. It's just two different ways of doing things, depending on who has to do the hard lifting. Because there is very, very easy to write Sparkle queries that would keep a RDF database, a so-called triple store, busy for about 10 minutes. You can do all sorts of things with Sparkle. It's a great, very, very flexible language, but also it is very resource intensive when it comes to do the actual querying. So you might want to hide that a bit and say, all right, we'll put more load on the client And then it just has to do smaller queries at the back end, and that's using triple pattern fragments. But that is not something we discuss here today. Right. So again, short recap. We have the Rdf data, triples or statements, subject, predicate, object. We talk about entities, connected to other entities or to text. That is a so-called abstract syntax. Things are defined by URIs. They can look very differently and have different expectations on different kinds of URIs. Resolvability versus persistence is what usually comes to mind. We have serializations of Rdf data, Rdf Xml, turtle, n triples, JSON LD. And we have ways to query that data using Sparkle if we have the right Rdf infrastructure at the back. So now we come to something that I touched briefly on at the beginning. And that is the use of two terms, one being the semantic web and one being linked data. And people quite often ask, is that the same thing? Not quite. And since it's not the same thing, what are the differences? At the beginning, what's a semantic web? That was the famous article by Tim Berners-Lee, Ora Lassila, and Jim Hendler in Scientific American in 2001, I think, where they started off discussing what can you do with the resource description framework and how is data supposed to interact and what kind of systems can you build on top of that. And at the beginning, it was very much into ontological reasoning, formal logics, first order logics. They had use cases like systems, PDAs were very modern at that time. Today we have smartphones instead, but that time we had PDAs, personal digital assistants. They should interact with each other and just organize things for you. One of the use cases they had was someone someone gets a phone call from his mother. She needs to see a physician. There's something wrong with one of her eyes. And instead of just starting to call around a physician, optometrist, he asks his PDA or gives a command, find an appointment for my mother with a physician today with specialty, and so on and so forth. And adding some information about his mother, if that wasn't as a profile on his PDA already. And then the system itself would start to go out and talk to the calendars of different physicians in the vicinity, looking at things like low barriers, because the profile said the mother is in a wheelchair, so it has to be able to go up with an elevator and all those kinds of things, and figures out, all right, you can get an appointment at 2:30 and orders a taxi for the mother to pick her up half an hour earlier, and the driver would know where to take her and everything. So everything just interlinked, and the information just passes flawlessly through the system, and everything you need to do as a user is to say, right, do this or find that, and the system will take care of the rest for you. Other use cases would be you're at a conference and the system, that is your PDA or any kind of backend system, browses through the attendee list, checks with your local address book and finds out that one of your old friends whom you haven't seen in 20 years is at the same conference, and it says, bring! Your friend is here, you haven't seen each other for 20 years. Shall I organize a nice table for dinner this evening so we can meet and chat? And they say, yes. And 10 seconds later, the system comes back and says, all right, there is a table booked at Poop. There will be a taxi picking you up at, And by the way, the restaurant is a vegetarian one because the friend is since 15 years a vegetarian. Checked out his profile. That was the vision. So they defined the data format, RDF, and a lot of heavy lifting on the formal logics at the back end. That was mainly Jim Hendler's work. He's the one who devised things like OWL, the web ontology language, and so on, and all those things with reasoners, how to figure out how things are connected and what those connections mean. And there were research grants put out, a few million euros or dollars invested, and nothing really came out of it. A bit disappointing, people felt, considering all the amount of money invested. And they started to figure out what was wrong. And they realized there is a lot of data out there doing that, but nobody publishes it. Nobody reuses anything anyone else had already done. And it was stored away in a desk drawer, more or less. So what can we do about that? All right, we'll make it easier for people to publish this data, and then to make it more reusable, we'll ask people to put links between different pieces or information entities within that data. And this, of course, goes very nicely with the web, the World Wide Web as we know it, being documents, and there are text in there, and that text is underlined and blue, and if you click on it, it will take you somewhere else. And RDF fits quite nicely into that one, because you've got things you talk about, which might be represented as documents, and you've got links in there that will take you somewhere else. Those are the predicates. You can think of those as links between two things, saying that this thing is related to that other thing. And what the semantic web gives you, or RDF gives you, what the usual web doesn't give you, is the exact meaning of this relation between two things. Because if you surf the web, you usually read the text, and the text that is this link will give you a hint of where you will land if you follow that link. Now, machines are pretty bad still at understanding text and context. They are getting better at it, but not quite there yet. And also the context or the meaning of a hyperlink in an HTML document is very, very contextual. You might have to read a full paragraph of text. You need to figure out what 2 or 3 links in that paragraph actually mean and where those will take you. So enter the semantic web where those links have specific meanings. So they thought, all right, we can leverage on that one. And up went the vision of making the web less document-centric and more data-centric. So what you have are that web pages, you still have web pages are fine, particularly if you have text that you can put on them. But if you have those web pages and say, this is not just text, those web pages are representations of something, be it documents or representations of people or places or things, concepts, books, for instance, like a bibliographic description in the library catalogue. If you start off thinking that way, you have the descriptions of things, and then there are hyperlinks that tell you how are those things connected. And by sort of merging the visual web or the document web with the semantic web, you turn the whole web infrastructure into one large hyperlinked database with the vision that everything is sort of connected to other things. And instead of just following hyperlinks, you think of it as traversing a graph of knowledge or information. And you know exactly, or you might know, and the machine will know as well what those connections actually mean. And that was the beginning of something called linked data. It's a bit catchier too, because it tells you what it is. It's data or information that is connected to one another. Semantic web has sort of a connotation, oh, that's very hard and very technical, and you have to know everything about first-order logic and reasoning and whatnot, and Rdf Xml on top of that, and so on. So they went into linked data instead and wrote a short list of 4 things that define linked data. There's a lot more text on the website I refer to here, but those are the 4 main things we talk about. The first one is, as with RDF, you use URIs to name things. That fits nicely into RDF, because in RDF2, you use URIs to name things. We still have already. The second one narrows that a bit more. It says use HTTP URIs, because those are resolvable. That's how URIs that start with HTTP, or nowadays with HTTPS, if you want to surf on the secure web, which you should want to nowadays. In order so that when you have a resource that is identified by HTTP or HTTPS, you can actually look it up on the web, grab the data and do something with it. Now, when someone dereferences, that is, looks up a URI on the web, an HTTP URI, give that person or machine or whatever information or data that is useful. And that should preferably be done using one of the W3C web technologies, be it HTML or XHTML or HTML5 or any flavor of HTML, or any flavor of RDF, be it Turtle, Rdf Xml, JSON-LD, whatever. Can be embedded into the same document, by the way, all of those. So when people look things up, give them useful information so they can figure out what it is. And those, of course, then goes into the RDF types that we spoke about. So if the machine encounters a description of a person, you actually have a statement in there that says, this is the description of a person. Because then the computer system can figure out quite a lot of other interesting things about persons, and perhaps store that away in a local knowledge system, saying, all right, this is information that I've found about persons. You might want to look at that closer one day. And the fourth one, being that this is the linked part of it. Once you've got that information in place, as a data provider, make sure that there are links in your description of things that will take you somewhere else. That's the linked part of the linked data. Link out. Make sure that people can get from your data to other related data out there. And that can be fairly easy. If you have a library catalog and you have publications in there, and those publications, you use an authority file to identify authors. You can easily build a hyperlink in your catalog from that bibliographic description to a description of the author. So for those of you who are into cataloging, you have got an advantage already, because every time you catalog a publication and you look up in your authority database and say, all right, this is the identifier for that author, and you put that into, what is it, $700 free or something? I think the identifier, the authority identifier for in Comark. Every time you do that, you create linked data. So you're doing this already. It's just a matter of getting the information out there, perhaps in a way that is not only visible in your own catalog, which by the way I don't think it is, for others to reuse. So that is the link out part of it. If you have a description of something, link out to related material, to related resources, and use the proper predicate, the proper link type, so that machines can figure out what is the relationship between the thing I've got here and the thing I've got there. So that is linked data. There is also the so-called 5-star scheme. I will do excellent on time. A so-called 5-star scheme for linked data, which is not only links, but goes deep into political issues as well. You quite often hear not only the term linked data, it's very often spoken to or referred to as linked open data. And those are really two orthogonal things. If they are, you can have linked data and you can have open data. And they can meet in the middle if you do things right. Open data is really the first part, the first star of this 5-star scheme. Make sure that your data has an open license. This is not technical at all. This is available on the web, it's technical. You need someone to run a web server for you where you can put in your data set. And that's fine. But in order to get the first star in Tim Berners-Lee's 5-star scheme, you have to talk to your management too. It's not enough just to talk to the person who runs the web server. Because you need to figure out, is this data openly licensed or not? I remember there was a long discussion, 2010, roughly I think, at the Conference of European National Librarians, at what should be the license of library data in Europe. And they agreed on saying it should be as liberal as possible. And this also goes very nicely with open data, because open data says it's available, and not only you can see it, like on a web page, but you're actually allowed to download it and reuse it for almost any purpose, except it being illegal, more or less. And even more important, you're allowed to reuse this data for commercial purposes. That means other people are allowed to reuse your data, or whoever puts out the data there, use your in a very wide sense here. People are allowed to reuse this data and build commercial applications on top of it. And this was a long discussion in the library community, and still is. At the German National Library, we had some discussion, and our Director General said data is useless unless people actually can do something with it. So we adopted the most liberal license imaginable. We put it out on Creative Commons 0, which essentially means the data is out there, you can download it, you can do anything with it, and you don't even have to say that it's from the German National Library. Which was hard to, we got a board of directors sort of surfing over our Director General to convince them why it's a good thing to give away this data, and why people don't even say thank you for it. I mean, we're happy if they say thank you, but they are not legally compelled to. And the reason we gave them was that if you think of an institution like Europeana, that harvests data from everywhere, and if that data would be under Creative Commons attribution required license, that means you have to say, I got this data and I got it from them. They would have a list of attributions that would be 2,000 pages long. because they've got so many contributors feeding into Europeana that it would be almost impossible to list everyone they got the data from. So we said, threshold as low as possible, easy to reuse the data. And that means we have very little control or very little knowledge about who actually reuses our data, particularly in Rdf. For Mark 21 we got a slightly different service. It still CC0, by the way, but it works a bit differently. But in Rdf we just put the data out there so you can reuse it. So I've been to conferences and people present something they've done with library data. And I walk up to them and say, oh, hello, this is nice, I'm from the German National Library, this is an interesting application. You've got some very good data in there, and I think we should talk about how we can connect our data sets, because I think we can benefit mutually. And say, no, this is your data. And it works fine, thank you very much. So that's the way we get feedback on who actually uses our data. So we have a page on our internal wiki where we actually list all this anecdotal evidence of who reuses, particularly the authority data. That's very, very popular. And try to get in touch with those people and say, are things working well for you, and what is the next thing you think we should do in order to make our data better? And usually they say, it's just fine. No complaints. And the complaints only come when the technical part of the infrastructure doesn't work. Sort of, we couldn't do HTTP dereferencing for 3 hours last week, so one of our services broke down. So that is, of course, one technical downside of the linked data part. You must ensure that your technical infrastructure is working 24/7. And if you have outages that you know of because you have to do server maintenance, you have to tell people at least 4 weeks in advance. And then remind them a week in advance and on the same day, saying, today between 4 and 7 in the afternoon, that service is not available. But we started to use load balancing and all sorts of elegant stuff at the back end. So that very, very seldom happens now. We've got very good people doing the infrastructure for us, and they've made tremendous work of making that more stable over the last 3 or 4 years. All right, so that was the open data part of it. A bit longer, 5 more minutes. All right. So the second star is to say the data should be machine readable, which means you just don't put an image up there, but you actually put a data format that machines can read. That said, images can be machine readable as well. You've got things like TIFFs or JPEG 2000, where you actually can put data into that image that machines can extract and reuse. But you sort of don't put a picture of the table up there, but actually put the table using CSV or Excel. I think it says Excel, right. So that makes it machine readable. You can download the data and process it using machines. The third one is use open formats. Excel has turned into a more open format since they started using what's called XSLX format, which I think is an ISO standard. But in order to make that more easily processable, I would urge you to use comma-separated values instead. You can do less with it, but it's much easier for people to reuse. And it's a truly open format, not controlled by anyone. Right, so the fourth star would be, and this is where it's getting a bit web technical or web political again, this is after all a W3C recommendation, is to use open data, machine readable, open formats, and now we go into semantic web, RDF land, and say use RDF, which means either you put it out as Rdf Xml or Turtle or so on, or you use something called RDFA, that's RDF in attributes, which is actually embedding all this RDF information into a web page using HTML. There's a way of doing that. It's not very pretty, can be a bit hard to do, so perhaps the easiest way instead is to put the whole JSON thing
into the web page and just deliver that with together with the HTML. But that is, use RDF is the main thing they urge you to do. And you can do that together with HTML. That technology to do that. And then we come back to the fifth one, which is the same as number 4 in the linked data meme, is link out. Make sure that people can come from your data to other data, which is of similar kind or somehow related to it. You can easily also say this is not related. I've got a person here, and they've got a person there, which is the same, has the same name, and you can link them together saying, this is not the same person. There are ways of doing that too. But it's really provide the links out there and type those links, that is, give them a type or a semantics, so that you come from one to the other and know exactly how those things go together. And with that, we realize we are almost at 11 o'clock, so we'll have 20 or 30 minutes for a coffee break, and then we'll reconvene here. So, before we move on, just a short recap again of what we did this morning. We started out with looking at what RDF is and how that works. Subject, predicate, object, triple statements, building knowledge graphs, talking about entities, talking about so-called literals, that is text, how we can formalize those entities we talk about using vocabularies that define types of things, so-called classes, and defining the relations between them in order to make things not only machine readable but also machine understandable. We talked about URIs, uniform resource identifiers, and the different flavors of those. We talked about classes and properties and hierarchies of those, looking at literary works divided into poetry and novels and short stories and so on, and also about hierarchies of properties. So we can talk about labels, if we just want anything that is human readable for a resource, and we can go down to say this is the preferred name of a person, or this is the secondary title of a book, or whatever. Then we went on to talk about the technical part of things, looking at RDF serializations, as opposed to the abstract RDF syntax. Those ellipses and text boxes are the abstract syntax. We talk about entities, text, and relations. And in order to make that machine understandable, we need serializations. Looking at Rdf Xml, Turtle, JSON-LD, and triples as examples. Having a brief look at Sparkle. Now you just check here. Right, having a brief look at Sparkle as the query language. How can one extract this data if we just have a long graph of things? And finally looking at linked data versus RDF versus the semantic web. They are similar, they are connected, but not the same. And finishing off talking about the so-called 5-star schema for data, not only linked data, where the first point is more political than technical, because it goes into licensing. It's not only getting your hands on the data, but actually to know what can I do with this data without having a letter from a lawyer the next day saying, sorry, you're not allowed to do that. You can look at it, but you can't really use it. So licenses are there to help data publishers and data consumers to figure out where is the common ground. It's security, in a way. And the 5-star scheme ended up with the same, that is the fourth point in the linked data meme, is link out. Make sure that when people find your data, they can come from there to other interesting pieces of data too. And that is what the linked in linked data is all about. So now we go a bit deeper into data exchange. This is the semantic part of it. What does the data mean? We all know the Tower of Babel, and I can tell you there are such towers in the linked data world too. People use similar terms to talk about different things, and there is conversion, or we converge towards sets of, or ways of describing things, but not everyone agree with everyone else on how to do it. But this is a crucial part, because if we want to exchange data while keeping the semantics and making sure that everyone understands what is meant, and also that everyone understands when I say this, I mean that one and not that one, we do need a common language. And people tend to say, well, it's just Rdf, isn't it? That's a common language. No, Rdf is not a common language. Technically spoken, yes. Semantically spoken, no. Rdf comes with some semantics, how to process the language and so on, but with very, very little semantic about what does the data actually mean. And that is where we need to converge a bit. It's an abstract syntax, we spoke about that, but the semantic of this graph is, there is a kind of semantic. Rdf knows about subjects, predicates and objects, so it knows what the triple is and how to traverse this graph, but it doesn't know what the data actually means. Whoops. So that's why we needed to add the Rdf type, and we need to say this relation does mean, and if I say title, I mean Dublin core title, I don't mean courseware title or academic title or any other kind of title. So that's where we start using the vocabularies, or sometimes referred to as element sets, because they define the elements we use to describe data. And there are quite a lot of them that in the linked data service at the National Library in Germany we use every day. The easiest one of the first, that was defined semantically very loosely, but was the first step, is Dublin core, which is now, how old, 25 years? 20, 25 years? It's been around for quite some time, can't quite remember when it was. Which was fairly loose, but at least we say, all right, there are things like titles, there are things like creators, translators, different kinds of documents, so we can talk about those. Then when the semantic web came up, and we needed to formalize things a bit more, they refined that into the Dublin core metadata terms, which we usually abridge DCT or DC terms. There is the bibliographic ontology, that is geared towards bibliographic data. It defines kinds of documents, saying this is a book, this is a periodical, this is a dissertation, which is a specific kind of book, and so on and so forth. So we've got this hierarchy again. We've got publications, we've got books, and dissertations are special kinds of books. We've got something called the Simple Knowledge Organization System, SKOS, which is for subject access vocabularies to describe subject headings and how those are related, taxonomies, classification schemes, they all go into SKOS. At the German National Library, we developed something called the G and D Ontology, which is how we describe our authority data, having 7 main classes, which I can't always remember all of them, but we have people, corporate bodies, events, geographics, got works, and a few others that I keep forgetting. And then they have subclasses, of course, of that one as well. So we've got, in geography, we've got places, we've got rivers and seas, streets and so on, all being different kinds of geographic entities, and so on. We got friend of a friend, we spoke of that one. That was one of the first Rdf vocabularies to come out to describe people and organizations and how they are linked together. It was one of the first use cases really on what you can do with RDF data was found. So people started to model their networks, and one of the main relations it had was knows. That a person knows another one, saying, I know you. And it's of course interesting if that person linked back saying, yes, and I know you too. So you can start to match those linking frameworks, see if I claim that I know you, do you agree with that one? Or people just claim that they know someone and they didn't. We've got Rdf Schema, which is heavily tied into RDF. It's called RDFS. It was the first notion of classes got into Rdf Schema. You could start of grouping things together because they had common semantics or common meanings. And on top of Rdf Schema, they then developed OWL, the web ontology language, which is one of the beginnings of the semantic web. It goes heavily into semantic reasoning, first-order logics, really trying to extract knowledge out of data and to find new relations between things you didn't know before. So you did use machine processing to tell you things about your data that you didn't know. And also, which was important in life sciences, is that they used OWL to feed protein models into a semantic reasoner. And if the reasoner said, all right, this all seems reasonable or seems fine to me, they said, all right, then we don't have to do research on that anymore. But when the semantic processing said, sorry, but there's inconsistency here. You say that those two things are related and that A is a subclass of B and C is a subclass of D and that they have commonalities up here. But you also say that, by some techniques, that this is an instance of that class and those two classes are disjoint. So you know two individuals can be a member of the same class. So you've got an inconsistency in your model. And that was a flag, sort of a red flag to the researcher saying, uh-oh, there's something wrong how we thought those proteins worked. So we might have to look into that one more seriously again, defining new experiments to figure out how is really the interrelation between those different molecules that build up the protein. And actually had some very interesting results by doing that, just by someone saying, or a machine in this case, sorry, there's something wrong with your model here. It's not logically correct. Look at that one again. So that was the web ontology language, what that one is for. Now, when we select vocabularies, we also need to think of what is the data we have. And by the way, if you look in your scripts are different from what I'm presenting now, because this is the part of the presentation I rewrote yesterday evening because I wasn't quite satisfied with it. So perhaps afterwards, sometime, we can distribute at least sort of the next 15 slides. I think will be different from what is in your script. So this is new. This is brand shining new, and to me too. So when we look at the vocabularies that we want to use to describe our data, it's very important to consider what is the structure of the data I have. What is the semantics that's inherent to this data? So we can start with unstructured data, like the one at the top. This, by the way, I picked from the national database here. And using those nice links you've got in your catalogue to download the data in different format. So the top one is, what's it called? Simple Unstructured Text Record Format, SUTRs. Exactly, that's the one. Which you could parse into pieces by using the full stops and a few other things to say, all right, this ought to be an author name and that ought to be a title. And you've got actually text saying down that this is an ISBN and so on. And the question is, how much can I rely on actually picking those pieces out of the data, and what semantics, what vocabularies could I use to publish that as RDF. Then we've got what I prefer to call semi-structured data, like ISBD. Mind you, I'm not quite sure this is proper ISBD because I wrote that by hand, but it brings the general gist of it at least. Where we've got more what do you call them? Like slashes and full stops and colors and so on. More characters in there, splitting it out in its constituent parts. And it's always been a thing that I wanted to look more closely into, is if you could write a formal grammar for ISBD that you could feed into a computer algorithm that actually took ISBD apart, and that is uniquely. So if you've got a computer science graduate who would be interested to look into that, just send him to me. I've got a task for him to say, this is the ISBD definition. Please write a formal Backus-Knorr format grammar, feed that into a compiler, and tell me if you can take ISBD descriptions apart into the different things that is supposed to be built off. I'm not quite sure it would work, the things the ISBD community says, but I would want to be able to prove it. But anyway, that is semi-structured data, so it's got more structure, and it should work in perhaps 80% of the cases to really say, this is this one, this is that one, and I think there are some edge cases where it might not work. Now, when we, because the point with this here is, we only have text. We have no identifiers except for the ISBN, and the ISBN really doesn't identify for this piece of text. But it doesn't tell me where can I find more information about the author, for instance, or about the place where it was published, without having to actually search for that information in the database, and then I wouldn't be quite sure if I found the right author or the right place because of the homonym problem. So that is where the identifier part of it all comes in. That's why you put the author identifier in $700 for instance, in order to say, all right, it's that one down there. And even though there are 15 John Smith in our database, this is the right one, the one I'm talking about, who is the real author. So that is why we try to tear things apart a bit in the bibliographic description. And in the German-speaking part of the world, this is very, very different in a way from the way things are done. For instance, in the US, they are not so much into authority control as we obviously are in Europe, and that is a common topic of discussion, for instance, on the BibFrame list, which Europeans find very hard to understand. What are they talking about? And the point is, they have authority control not through identifiers, but by trying to just describe the author as much as necessary by adding birth or death years and so on and so forth, which means that, by the way, when the person dies, the identifier for the person changes because you add the year of death to it. And that is easy for people to understand and hard for machines, because the identifier looks different depending if they have added the death year to the description already or not. So if you are into authority control, very, very good for you. That will make the transition, or at least publishing your data as RDF, a lot easier, and the data will be much more useful to people out there. Now, so what do we have here? All right, yes. This is one of the books we'll look at this afternoon. I won't say it in Slovenia, I can't do that. It's a book from Sweden, Anna, Hanna och Johanna. And what we do when we catalogue is then to say, all right, this is what we have here, the blue text hyperlinks. The reason we have them in there, in the catalogue, is because we have them in the bibliographic database. This information is created at cataloging time. perhaps refined later by machine processing, usually not when it comes to those kind of things. But it's in the bibliographic database, and all we do in IT then is to transport that into the user interface. And the same applies to the subject headings down here. And if we went on to look at the description of the author of the subject headings, there would be more links in there, linking the author to all the books she wrote. Of course, the reverse link is in there. And also to things like birthplace. I mean, I think she's still alive, so she's not, there's no death place. Places where she had lived. Subject headings describing her profession. She's an author, but she might have done other things too. There are quite a lot of authors who also work as university professors, and that relation will be in there as well. And also down here, at the subject headings, how those subject headings are linked together, forming a taxonomy hierarchy. So it's just a matter of creating the links and of bringing them into the end user interface. But the point I was talking about mainly was we don't look at publications just as monolithic descriptions, but instead we try to tear them apart a bit and say, all right, we've got the publication, but we maintain the description of other things that relate to this publication separately. That's why we have authority files. That's what they are for. Now, there is a recent tendency, though. No, I'll talk things first. You have this in your data, but yesterday evening, while looking at this, I also looked at your catalogue, and I was astonished to see that you don't use it. I would have expected to have this as a hyperlink to the description of the author, linking to your authority file. I guess you have your reasons for it. It's technically a bit harder to do, but it's a lot of value for end users to get a greater context of everything you have in your catalogue if you start interlinking, not only interlinking the bibliographic data, but also to show those links, to make them boil up into the end user interface. Because that would show people that this is linked data. So if you go to Marianne Fredriksson, you will get a description of her from your authority file, perhaps a link to VIA. You're not in VIA yet, are you? Right, but the day you are in VIA, which I think will come, that could be a link to VIA too, coming in there, to give you more context, more information about the things you have in your catalogue, including the list of other publications that Darita Shoban has translated too. That could be very interesting. And it also has, then goes into what do you call it, not authority control. It's about rights management as well. It's sometimes very important for authors or other people who have intellectual property rights to those things to say, look here, the National Library says I translated that book. So those rights for the translation belong to me. And no one else can take that away from me. And this is also, at least to me, an important part of the job done in national libraries, is to feed into intellectual property rights networks.
I have to say here that there are a lot of problems why we cannot do that.
Mm-hmm.
First of it is that we are, as NUC, the National Library, is not owner of the authority files, but I don't know whether with the Institute of Information Sciences could be done something, or maybe just to think of this, because it would be really nice to have some more information on that. I don't know, that would be really fantastic, because the data is there, but as you said, we don't use it enough. Maybe that's why also, maybe we can speak about this during the lunch, how to approach this problem, because it would be really nice to provide these connections to the authority files. So.
I also want to flag, this is not meant as a critique.
Yes.
I'm not saying this because we, and 15 years ago, our catalogue worked very, very differently from the way it does now. And I found it very hard to navigate that one, and so did some of the other people in our part of our librarians and other people in the IT. That's why we embarked on a very long journey of revamping that catalogue, and now it's built completely from scratch. A new end-user search interface is being done, which is a 2-year project. So this is hard work. It's valuable, it's not easy, but it's worth doing, and it's careful planning. So just don't walk away, all right, we just do this and that. No. Get your requirements right, talk to your users, talk to anyone who's involved in creating this data before just going running off and implement a new system. We've been there, we've done that, and I don't recommend doing it. That's why we reorganized IT, I think 3 times in 15 years, in order to get that right at our place. But I'm digressing. By the way, what I also thought of, what we discussed during the coffee break, is it would be extremely nice to have another hyperlink here saying turtle. So to download this data in turtle. Also on the requirements list for the next system. Not now, later. But the point I wanted to make is, you have the data. You have the data, you don't have to recreate it. You have the data, and just try to make the most of it. You don't need to change anything in cataloging or anything. Just reuse the data you have the best way you can. And that is more a technical problem than it is a bibliographic problem. And as I understand, it's also in a way then a management problem, because you have different ownerships of the data. At our place it's much easier because we run the authority data and the bibliographic database. So it's all in one system. So it's much more interlinked with us. Right. So this is what I really wanted to talk about, is the decomposition of data. So we talked about decomposing the bibliographic description into the publication as such, and that is linked to authority data. Now, since 1997, or in 1997, there was a publication coming out called Functional Requirements for Bibliographic Records, FRBR, or often referred to as further, because that's easier to say, which very much changed the way we look at publications. And further fed into something called RDA, Resource Description and Access, which is a new cataloging code being developed. Now, what has that to do with bibliographic descriptions and what we talk about here? Well, it is really this part, the question, how much can we pull a publication apart without it being unwieldy or unhandly when we do the cataloging? And also, which part of such description can be useful on its own without really looking over the bibliographic universe that can be reused outside of libraries. I'm very much concerned with the reuse of library data outside of the library world. And if we look at things, and then a few years later comes something called BibFrame, now in its second iteration. They also devised such a model of the universe. Further, started with works expressions, works being the very abstract thing, like Beethoven's Fifth Symphony or Shakespeare's Hamlet or Macbeth or whatever, going into specific, variations of that work, be it Beethoven for a full symphony orchestra, or rewritten for a string quartet or piano solo or whatever, with text resource, we for instance speak about the first, the second, the third edition having amended texts, or for instance different language variations. Would that be further word here feed into the expressions? The manifestations is that what publishers produce. They've got things like ISBNs and so on, so you can differentiate between different editions from different publishers. And down at the bottom we've got the items, which is a sort of the physical thing, or at least with usually common print publications. With digital publications it works differently, of course. The item, the thing you can put in a shelf, that will get the call number in the library. And on top of, beside that, they put different kinds of authority data. Oops, that's the wrong one. Oh, there we go. Person, families, corporate bodies. And down here we've got everything that is sort of the subject access thing, phases, events, and so on. All feeding into one common model in RDA. So you've got the further RDA way of thinking, which is a fourfold model with authority data beside it. BibFrame took a different stance and created a three-tier model having works, which is more or less the same as work and expression in further being taken together. They call the instance what further RDA calls manifestations, and at the bottom they got items. This is, by the way, the version 2 of the BibFrame one, which is only a few months old now. So the question is, they tried to pull this bibliographic description apart. And there's been quite a lot of critique with further, particularly with the expressions, because they're so hard to grasp. And there's some people, in some cases, they don't really make sense. They don't have expressions of manuscripts, for instance. They're just one thing. So in BibFrame they did it a bit differently, putting those two abstract parts together, which makes it easier for cataloging, but in my view hinders the reuse outside of the library sphere a bit, because it gets so text specific in a way, talking about different languages and so on. Whereas further RDA work, it makes sense outside of libraries to talk about works. I can talk about a specific poem without having to think of what language of this, or do I talk about translations? I can speak about the Harry Potter septology without having to say, right, I mean exactly that volume of it, or the 15th imprint or whatever, or did she change the text between the 15th and 16th imprint, or those kinds of things. So I think that the work as defined in Verb RDA is a very, very useful entity, because that is something that people outside of libraries can understand too. And I do agree with everyone who says that the expression in Verb is extremely hard to grasp, seriously underspecified. And so with my librarian hat on, I agree with the BibFrame people who say, right, we just put those two problematic fields together and make one entity out of them. So the short version of what I'm telling you here is there is no right thing of doing things. It's a matter that we have to agree on how we do things. And sometimes we all can agree that we don't agree. And some can say, no, sorry, that doesn't work for us. We'll do it this way. You'll do it that way. And we try to see whether there is common ground, how we can increase interoperability. But there is no one size fits all. Not even in libraries. What's coming next now
is a sort of experiment. It's a thought experiment, though. Nothing that is implemented, but a short look at how we could use the different versions or the different levels of those decomposed descriptions to make access to bibliographic information more, not palatable is not the proper word, but looking at the reuse component of bibliographic descriptions. How can we make data access or information access better at a global level? And I'm using the further model when we describe this, and sorry, I'm not using that yet. We'll look at that on the next slide. And first we'll talk a bit about models instead. So, we have models. We just talked about BibFrame, we talked about further RDA. I refer to those as hierarchical models, because there's sort of a hierarchy. It's not a real hierarchy, but you've got different kinds of entities that are linked together. You don't have just one big description of what you have. So we've got further RDA, we've got BibFrame. Who is familiar with schema.org? It's a vocabulary that was invented jointly, you must say, by Google, Yahoo, Yandex and Bing, that is Microsoft, in order to help webmasters mark up their web pages to tell search engines what this web page is really about. And as Richard Wallace, formerly of OCLC, used to say, when you hear the words Google, Yahoo, Yandex, Bing and collaboration in one sentence, that is a sign that there's something into this. Because they really made this together, those four industries, to make it easier for search engines and for webmasters to get their data into the search engines and to make search better for the end users. So they defined a vocabulary talking about things like products, going down to computers and cars and so on. So if you have a platform where you sell used cars, you could describe that as saying, well, this is a car, it's got this make, so many kilometers run, it's that old, runs on normal super motor spirit and so on and so forth. And there are like Rdf vocabularies or terms or properties to describe all of this, so that search engines can make sense of it. So that when you go to one of those search engines and say, well, I'm looking for used cars, it should be about that old and that make, and so on and so forth. The search engines will be able to give you a better result set, more narrowed down to what you're really looking for. And there is, was, an interest group saying, all right, we need to do something similar for bibliographic information. So they choose a two-tier model, saying, right, we talk about things, the real book, what we would call an instance or a manifestation, and we talk about works, so-called creative works. And the book is sort of an instance of creative work. So it shows something that's very similar to the BibFrame model. And then you can go off and buy this book once you found it at Amazon or in your local bookstore, if that is linked to the web. So we've got those hierarchical models or multi-tier models, you might want to call them. And then we've got things like the single level or flat models, where the whole bibliographic description is just one block of text without really being torn apart. One of the most used one is ISBD. A MARC record is very much similar to that. And when we come to semantic web, in Germany we implemented something called the D D model, which is essentially an application profile. That was because when libraries started to talk about linked data in Germany, there was quite a lot of interest. So we started at the National Library, and some of the major library consortia started to look at linked data.
and some of the major state libraries did the same. And unfortunately, we didn't talk to each other while doing this. So we ended up having 5 different application profiles, that is, ways of describing data when it comes to RDF, and they didn't really look the same. So we figured out, if anyone wants to build applications on top of RDF data from libraries in the German-speaking part of the world, that is Germany, including Austria and parts of Switzerland, they would have to have 5 different ways of parsing that data and figure out what does it really mean. And after about 2 years, we said, this is complete nuts. We need to agree on how to describe this data, just as people do with mark and everything. I mean, those are agreements on what things mean and how they're supposed to look like and what they can be, how they can be used. So within the auspices of the German Institute for Network Information, DINI, there is a working group called the Competence Center for Interoperable Metadata, short KIM. We put together a working group that decided, first, right, what should an RDF metadata profile for libraries in Germany look like? That was, I think, 4 years ago. And they worked for about a year, published a recommendation. Everyone implemented it. So, right, we do that like this. The data was interoperable. We could just more or less pass data in RDF back and forth, just we pass data back and forth in Mark 21, and it worked. On the way, we found, while implementing it, some people said, there's something missing down here, and that over here still isn't quite clear to me, because if we look at our data, we've got this problem. So we revisited that again for the last 8 months, and are just now finishing off the second version of this, what do we call it? It's not a standard, it's a recommendation. This is how we think things should be done. And people can follow that recommendation or they don't, it's up to them. But at least having this kind of application profile does make things more interoperable. We have been looking at RDA further, we have been looking at BibFrame and said, this is very interesting. We particularly need to talk about works, as in creative works. Speaking of books or literary works, no matter what language and so on, no matter first, second, third edition. Looking at films, how films can be based on books without looking at languages and those kinds of connections. And we said, we'll do that later. First, we just make sort of blobs of bibliographic descriptions, just looking at the publication, putting that beside the authority data, because the rest is too complicated right now, and we simply don't have the data that neatly put out in our bibliographic systems in order to make that full transition to a more work publication-based model yet. Might look different in 5 years' time. So that is easier. Also a lesson we learned along the way. Don't over-engineer. Look at what the data you have. Look what you can do with it. And also look at what you can't do with it. Saying, sorry, I can't make that commitment. We don't have enough confidence to say that that is right or wrong. So, hierarchical or multi-tier models versus single-level models. The single-level, the flat models are much easier. Not as neat, but they work. But now, if we start looking at multi-tier models, they of course get much more interesting because you can do more things with them. And they do offer some opportunities to link things together and to reuse data in things that in ways that we can't write now. Now, this is very much into the blue. I don't know if that will ever come. I hope it might. But we simply don't know. I start out with a book in Swedish called 100-åringen som klev ut genom fönstret och försvann. We'll see that in translation later. Written by someone called Jonas Jonasson. Now, everything that is blue here are things that you could consider coming from the Swedish National Library. Because that is where the book was first published. It's published in Sweden, it's part of their legal deposit. They ought to be the first who encountered this book at all. So we start out with the blue things. So they create a work using the Ferber model, or that they would create a work. When I say they do things, it's they could do if they work like this. So they start by creating a work. Then they create an expression being that work in Swedish. Then they create a manifestation saying this is a 2009 edition by, it's not Bonniers, someone else. I can't remember who was the first publisher of this one. Could be Bonniers, could be Rabinov Högren. Never mind, that's not important. And a lot of items. I think they got 15 or 20 copies of this one. Throughout Sweden. There will be hundreds of it throughout Sweden. Fairly clear. First publication. Then, a few years later, this was translated into German. So there will come, through legal deposit, a German translation of this book in the German National Library. Now, in order to reuse data, the German National Library would not, should not, using this model, this workflow, mind you, create a new work, because the work is there already. They would just create a new expression, saying this is this book, but in German. And they link that up to the work thingy, I don't say record, the work entity, already created by the Swedish National Library. They also add more information, saying that this was translated into German by Wiebke Kuhn. And they add a manifestation saying that this is the title, published in 2011. I can't remember the publisher here either. That's not really important. And two manifestations. No, sorry, two items in the German National Library. We have two separate buildings, so you've got one item going to one of the separate stacks. Now, a few years later, you get this one. I won't pronounce it. Which is the expression, but in Slovenian. Again, you do the very same thing. It's a story of an old man who is sick and tired of being in the old people's home. So when they're celebrating his 100th birthday, he just climbs out through the window and disappears. And has all kinds of adventures along the way. And he also tells his background stories. When he was young, he worked with intelligence by chance. He had no idea what he really was doing and so on. It's a very hilarious book, was filmed later, and well worth to read if you need something for the summer holiday. All right, translate. This is interesting. All right. You add a translator to that expression, because expressions are translated. These expressions are translated, and if different people translate the same book, they create new expressions because there's different text behind that one. We have a first edition in 2013, and then an item for the legal deposit, and the second one for 2014, and so on and so forth. There are new editions coming all the time. I think I found 15 records or something here in the database. Right, so where do we go from here? What have we learned? Well, we have seen it makes sense, or rather, we can reuse data. We can reuse work information, which is who created or who wrote this book. There's nothing in the local databases, would be nothing here or in Germany that has creator or author information. So let's reuse that, what the Swedish National Library has already done for us. What we do is to add the things that are specific to our publications, like translators. The Swedish National Library will, of course, know who translated things, because they get it by legal deposit, but they buy all translations of works being translated from Swedish into other languages, which is the same thing as we do in Sweden. I think the same thing as you do here as well. You do buy translations of Slovenian works into other languages, which is part of what a national library should do. So, yes, we're on the same page there. All right, so we reuse information and we add new information on the way, where it is appropriate. Now, right, so those are the things the Swedish National Library would buy from the different countries and add to their own collection of things. So let's take a step back again and look at where this takes us. Now, when the Germans, they were very thorough, my colleagues, when they did this, so they added subject headings and DDC classification, putting in 839, and the B means belletristic, which is essentially literature. And talking about this is Swedish, they are talking about men in old age people's homes, escape, thank you, and how that is handled in fiction. So it's a fictional story. The Swedes added first something called HC.01, is their old classification system. This is Swedish works in Swedish fiction. That means HC.01. And later they used that to map into the 22nd version of the duodecimal classification, giving it 839.73, which by the way is not correct, but that was done automatically by machine. So they need to tweak that a bit later. They realized that because when they got the German data into bought the German publication, they catalogued that one too, and realized this is going to be an 839.738, which is translation from German. So the 73 is a bit inexact. Then in Slovenia, we got first the expression to items, there's expressions and manifestations, and you added subject headings too. What does that mean, by the way?
Universal decimal classification.
Yeah, we did, yes, but the subject heading. Adventures in literature. All right, that's good. And a UDK heading. I'm sorry for the garbled look of things here. It looked fine when I did it yesterday.
No problem.
And then when the Swedes got the first edition, they only bought the first one, interestingly enough, the 2013 one. They added subject headings too, which means old age people's homes, escapes. They added LCSH, which I think they did automatically. Also link their subject headings to LCSH, so just pull them in from that. Sweden and the 20th century. SAO is Svenska ämnesord, that is the thesaurus they use in Sweden for library classification. It's a fairly new project. Right, so we right. So, now, the interesting part is, using this model, or so far, it was not interesting to see the subject headings and all kinds of classifications. When we catalogue, we add that to the manifestation, which makes things harder to find, particularly if you look at it in a global context, because you have to search through very many databases in order to find the subject headings or the topical the topical part of things. In this theoretical model, those things should really be up at the work level, because you don't classify manifestations, but when you do subject access, you do subject access to a work. Because that is what we really talk about when it comes to topics. A work has a certain topic. So if we could move those things up there, I just move the German things for right now, talking about old age people's homes and men. And then we use something called Max. Who knows Max? It was a project between, let's see how I get this right, OCL, no, it's not OCLC. It was the German National Library, the French National Library, the Swiss National Library, very important pattern, and the British Library and the Library of Congress, to link subject headings from different subject heading vocabularies. Being the German one, at that time it was called Schlagwortnormdatei, which is the topical, which is now part of the integrated authority file, topical headings, subject headings. In France, you got Rameau, which is something répertoire unifié, and something in between, which is the French thesaurus for subject headings, and we got the LCSH. And the ones who really moved this forward were not the Germans, not the French, not the Britons, but the Swiss. Because the Swiss have a language problem at their front door. Having four official languages within one small country, and they are all at this very similar level. Heterosexualization, which was sort of pushed aside because so few people speak that. But you've got French, you've got German, you've got Italian. So they started with a project loading subject headings in French, German and English into a database, and then had staff, subject experts, starting to link those things together, saying that this word in one language has the equivalent meaning, this term, not just this word, this term in one thesaurus has the same meaning, or at least a very, very similar meaning, as another term in another thesaurus. Also creating what they call triples, because they have three subject vocabularies, linking those three together at an equality level. And lately, as a part of a technical experiment, they also loaded the nuovo societario in Italian into the database and started linking those two. But there are very few links to that one, so we don't really talk about that one. Went on for a few years. The system is now frozen, and the data is available for download. Talk to me if you want to use it. Anyway, those are the links we got up there. So that means, if we use that system, we can start by searching for maison de retraite, figure out that that is the same as Altenheim in German, and that is linked to the work up there, and from there on, we can traverse this graph down here and find the Slovenian library without having to know Slovenian. Might not be very important for fiction, but if you consider this for scientific literature, which might or might not be available in translations, but only in certain libraries, and then figure out, right, there is a publication here that might be important to me, and if I can just get someone to translate the abstract for me, even if I don't know the language, I can figure out, is it worth translating the whole publication? Is it that important? Or do I need to get help from local scientists who understand that language and the context in which the publication was made, in order to say, is this important to me? Can I reuse anything from that publication? And even this might be very important in sociology, because when sociologists do the research nowadays, they often look at popular culture as well, not only at the scientific data, but also see how is this topic treated in popular culture, in films, in literature and so on, and take that in as part of their research too. So having subject access sort of at the top of this, well, I don't like the word hierarchy, split level system can be a very good advantage, because it gives you access to literature no matter in which language you search. And it will also be much easier to find a copy of this publication near you, because they can sort of split this geographically and say, all right, I'm here. Are the libraries within 20 kilometers of where I stand that have this or a very similar publication? And I let those things stand down here with the LCSH from the Swedish National Library, because as you see, they have here older people and housing from LCSH, whereas in Max you are the old age homes. So it might be that you use this system as well to flag to the subject indexers, you might want to revisit this part of your subject indexing vocabulary to see how does that work in a pre-combined environment, and how does it work in a post-combined environment where you don't make long subject heading phrases, but where you treat them differently as atomic parts that are linked together when you do the actual subject indexing. And from what I've been told by computer scientists, I'm not one, having atomic parts, it's much easier for computers to relate to one another and not tearing strings like those apart into their consistent entities and have that linked together. So it would be better for a computer to have older people and housing as different entities and thus build them together the moment you need it. But there's a different ways of looking at subject access, and I'm not a subject access specialist, so I believe anyone who's willing to tell me anything about it. Now, the question then, of course, when we look at this, is we've been looking at models and we talk about interoperability, is to see how interoperable are those models? Can they work together? I usually say, let's start differently. At the left-hand side, we have the further way. WeMe is sort of a work expression manifestation item. So it's the further RDA model. On the right-hand side, we have BibFrame. Here I only took works and instances. And someone said, all right, in order to make those work together, all we have to do is to create a profile that sort of translates between them. The interesting part is that when they did this, they only showed how to translate from RDA further to BibFrame. And no one told me how I could translate back again. The main question being, if I have a BibFrame work and I want to put that into RDA further, is there a way that I can decide which parts of this work is the further work and which part is the further expression? Mathematically spoken, you would say that you've got a bijection, so that you can move the data back and forth losslessly because there is a one-to-one mapping between them. And this question that I've asked a few times and that no one really answered is there a bijection between RDA further and BibFrame? And if there isn't, the data will never be truly interoperable. You will always lose something when they go back and forth. And if there is a bijection, why do we need two different models? Because we have the same expressivity, no matter how you put it. But this is research. There is no answer. We have a lot of questions dealing with this, and we have no answers. And maybe there will never be an answer. So the important thing when you decide how to do it is simply to say, all right, we do it this way, we know about the consequences, and we can live with them. But as always, there is no one answer. And if there is one, it will be 42, which essentially means, for those of you who read the Hitchhiker's Guide to the Galaxy, that you're asking the wrong question. Because interoperability is also a function of who you interact with. I mean, we've got those silos of data. That's what we talk about all the time. And we try to build those silos into a network of data. And in order to do that, we need to speak roughly the same language. We need to agree on what kind of things we talk about. And we need to ensure that the data flows function. That might mean that we need to use different workflows, different kind of data representations, and different semantics, depending on whom we talk to. Between libraries, I would say that interoperability is very, very important. Because we talk about the same things, we need to agree at least on a fairly common semantics. What kind of things do we have? What precision of description do we have? That's why Mark is so complicated as it is, because it's very, very precise. And the point with libraries is information flows back and forth. It's a two-way street. If we go to search engines, for instance, if we want, as we said at the beginning, if people look for information nowadays, they don't go to the library. They go to a search engine, Yahoo, Bing, Yandex, Google, and search there. So we need our data to be in there and able to be found. And the better we can represent our data in a way that search engines can understand and process, the more traffic will flow back to the libraries. So I usually say search engines are not our enemies, they're our friends, but we need to brush them the right way, not against the grain. And one of my favorite, the thing I want to see in future is that when someone searches for a publication or an article or whatever, there will of course be hits going to Amazon or one of those large online bookshops, depending on where in the world you are. And perhaps down at place 5 or 6 or 7 or something, there should be a link saying, this book is available in the city library, because we've got location-based services enabled on your phone. And that is 300 meters straight ahead, then you turn right, walk down the block, and it's on the left-hand side. And the technologies are in place to do that. Right now, we don't have the data to support the search engines. I don't know if the search engines are interested in doing that, but to me, that is very much a use case. Something that we should aim at getting done. Because again, that will drive people back to the libraries, and also realizing that even though search engines try to answer all sorts of questions for you, that's when you start typing, you don't always get everything you need. And sometimes it's much better to talk to someone who has knowledge about that topic than one is communicating back and forth with the machine. It also depends a bit on what kind of person you are. There are people who are more comfortable talking to machines than talking to other humans. And the other way around, people who absolutely detest using search engines and rather ask people in their vicinity, what do you think? So we need to cater for all kinds. The important part is that is a one-way workflow. We send data to the search engines, they don't send it to us. So that limits, of course, the constraints on the interoperability. It's sort of, they say, we need the data this way. If you can give it to us that way, perfect, we're done. And that is what this schema.org thing I talked about earlier is about. And no, we don't have schema.org at the German National Library yet. We'll probably have it as part of our catalogue in 2018, I hope. And then we'll also have so-called XML sitemaps in place that we can give to the search engine saying, if you just crawl this sitemap, you will get all the information from the library catalogue, nicely marked up with schema.org so that the search engines can understand it. But that's a different topic. Ties into it nonetheless. Other entities we need to integrate with, exchange data, are archives and museums. Because the cultural heritage sector is more and more growing together. Also triggered by applications or portals like Europeana. They collect from all kinds of archives, museums, galleries, libraries, and so on and so forth. And also those national cultural heritage portals. Like in Germany, we've got the German Digital Library, the DDB. There are similar things coming up in the US, the Digital Public Library of America, the DPLA, exactly. So this is also about metadata profiles, where you don't need the full description of everything. You just need enough metadata in order to figure out, all right, what is this resource we're talking about? Do I have enough text that I can index and find it? And particularly working with persistent identification of those things, so that when the metadata description is updated, you don't end up having duplicates in your database, but you have some kind of identifier in your data saying, all right, I'm sending you data again, it's about that thing. That's why we like using URIs, because they're unique. So you can just update your description for this thing and throw away the old one. So then we need some kind of interoperability. Not the full-fledged one as between libraries, but we need to agree on a core set of metadata. And those things are being done as well. There are application profiles coming from Europeana saying, if you do this, like that, you'll be fine. And this is the core set, and that is the extended set of metadata you might want to send to us. So coming back to the original questions, why should we care about linked data and RDF? Well, the point is, outside of libraries, they don't really understand what we talk about when we come with all those acronyms. As, of course, in libraries, we don't always understand what the particular technical community means, but they just keep bombarding us with acronyms that we have to look up first as well. But this was the beginning of the journey of linked library data. The story I told about the Swedish National Library cooperating, or not cooperating, with the students from the Technical University in Stockholm. And the students said, no, sorry, we didn't understand MARC, and we said 3950. Can't we have HTTP and XML instead? So they said, all right, if that works for you, we'll do our very best. Because the reuse of library information, or put differently, there is a lot of information in the data that library create and host every day that is interesting and useful for people outside of libraries. Particularly in Germany, when I was looking at extending access, and that is write access, to the authority file, to archives and museums.
because we talk about the same things. It's people, it's places, it's events, particularly people. They are almost obsessed of identifying people uniquely. And since all that data flows, or in a few years all this data will flow into the German digital library, if we use a common set of authorities, that will improve the access and thus the visibility of all those smaller institutions that usually drown because the larger institutions, the large museums, get so much more traffic. But if you go to the German Digital Library, and that little museum's data is in there too, and it's linked to the same person entity that the National Museum, the Germanic National Museum in Nuremberg, or one of the large museums in Berlin, and you search for that person in the digital library, the large libraries, the large museums will be there, and the little museum as well. Because you've got authority control, and you can say, all right, that's the person, and they have information about this person as well. And the same goes with the small archives. Anyone who's done historical research, writing to 15 different archives, do you have anything on this person? Know how tedious that can be, and I did my PhD before there was email, or before most archives had email, so I had to wait 3 weeks until I got an answer. And 3 weeks is, in today's research, eons of time, when you more or less expect to have the answer within 24 hours. So, easy to reuse, easy to mark up your data, and then of course also easy to plug into the system, like large cultural heritage portals or other portals. We work with publishers in Germany to nudge them a bit, to say, if you use our authority file already in your publication process, that will A, give you a standard set of authors you might have already. That's a good part for them. They don't have to keep a very concise set of the people they work together with. So that minimizes the work for them. And then, which we don't tell them, is that when they send their metadata to us, coming through Onyx or Mark 21, and the identifier is there, it makes the life of the library a lot easier too, because we already have authority control with the authors, and only have to check, is it the right one? It is, off you go. So there is value in collaborating on those things. Perhaps not so much in what we usually look at the core, the bibliographic data, but the authority data. That is, to some institutions, more than gold. And particularly, it becomes more and more valuable the more people use it for different purposes, and that's fine. And as I said, using linked library data, or making your data more linkable, and trying to push out those links, publishing them, is a very, very good start on this journey. It's not hard. You can start very, very small, doing one little corner, publishing that. You don't have to be very technical. You can create a data set and put it somewhere for people to download. You don't need to change much on your systems. Convert the data, put it on an FTP or an HTTP server, and that's a very, very good start. You don't have to convert all your data. That is, you don't have to convert every mark field into something that's RDFing. Look at, this might be the most important things for other people to reuse, and start with that. And then go on slowly, steadily. That is what we did. Our linked data service at the German National Library is completely different now than it was, I want to say 10 years ago, but 10 years ago we didn't have a linked data service. 7 years ago, when we did the first time. Our first one was in 2010.
And today it looks technically and organizationally completely different. Much more data, looking slightly different. So you can start small and then move on gradually. And there's no need to rush. Every little step helps. Because the point is, 2,000 years ago, almost, where Callimachus in Alexandria, he catalogued for his local library, which was supposed to be the world's library at that time. And today we catalogue for the World Wide Web. That is what people search for information. And the big question is really, how do we get from here to there? And that is what linked library data is all about.